Today, I present these two topics: properties of definite integrals and a dummy variable in the integral notation. Have a review first. Number one, an integral is a limit, the limit of this sum. Delta x times function value at xi star is the area of the ith rectangle. The sum of areas of rectangles roughly is the net area of the region S here. As the number of rectangles approach infinity, this sum will approach some number. The number is exactly the net area of the region S. Review number two. Let S be the region bounded by the graph of the function f and the x-axis and between A and B. In this diagram, region S is the shaded region. Then integral from A to B on the function f is the net area of the region S. By definition, net area is the total area that lies above x-axis minus the total area that lies below x-axis. Okay, now the first topic one, properties of definite integrals. Property number one, take integral from A to A on the function f. The integral is 0. This property is quite obvious. When the lower limit and upper limit they are the same point, in this diagram, when A and B they are the same point, in this case, the region S will degenerate into a line. A line has low area, and an integral is net area. So integral from A to A is 0. Integral from A to A is the net area of a line. It is 0. Property number two. Property number two. This is a convention. Okay. When we take integral from A to B, and when we switch A and B, then don't forget to add a minus sign in the front of this integral. So integral from A to B is negative of integral from B to A. When we switch lower limit and upper limit, add a minus sign. Property number three, summation subtraction rule. Okay. Integral of a sum is equal to sum of two integrals. Summation rule. Integral of a difference is difference of two integrals. Subtraction rule. Please note that for integrals, we don't have product formula. We don't have quotient formula. Property number four. Take integral on a constant times a function. It is equal to the constant times the integral. That means that we can move the constant c outside the integral. Property number five, splitting rule. Integral is net area. We can split the net area into two net areas. Integral from A to B. This is net area from A to B. I can split it into land area from A to C plus land area from C to B. Property number 6, total area of the region S. Integral is land area. Total area above x-axis minus total area below x-axis. But if we want to find the total area of the region S, total area, not net area. Total area means the area above x-axis plus the area below x-axis. If we want to find the total area of the region S, then what we can do? We can take absolute value on the function f. Here, the red curve is the graph of the function f. The blue dashed curve is the graph of the absolute value of the function f. When we take absolute value on the function f, the negative part of the graph becomes positive. Now, take integral on absolute value of the function f. This integral is the land area of the blue shaded region. The blue shaded region has no part below x-axis. Only all the shaded region lies above x-axis. So therefore, this integral is the total area of the region S. It is this area plus this area plus this area in this diagram. So when we want to find the total area of the region S, take absolute value on the function f, then take integral on the absolute value, then we get the total area of the region S. Now, let's look at some examples about the properties. Example 1. Assume that the integral from 0 to 5 on the function f is 3. And the integral from 0 to 7 on the same function is -10. Now, the question is evaluate the following integrals if possible. Now, A, find the value of this integral. By the constant multiple rule, I can move the number 2 outside the integral to get this equation. Now, 0 to 7, this integral is -10. So the answer is -20. B, find the integral from 5 to 7. We are given 0 to 5, 0 to 7, and we want to find 5 to 7. By the splitting rule, 0 to 5 can be split into 0 to 5 plus 5 to 7. I move 0 to 5, this integral, to the left side. Then 5 to 7, this integral is equal to 0 to 7 minus 0 to 5. 0 to 7 is -10. 0 to 5 is 3. So the answer is -13. C, find the integral from 5 to 0. We are given the integral 0 to 5. It is number 3. To find the integral 5 to 0, by convention, we can interchange the lower limit and the upper limit. But don't forget to add a minus sign in the front of this integral. The integral 0 to 5 is number 3. So the value of 5 to 0, this integral is -3. Now, D, find the integral 7 to 0 on 6 times f. 7 to 0, let me switch the lower limit and upper limit by adding a minus sign in the front. Then I get this equation. Now, constant 6, I move it outside the integral to get this equation. 0 to 7, this integral is -10 we are given. So the value of this integral is +60. Part E, find the integral from 0 to 7 on the absolute value of function f. By formula, by property, this integral is, total area above x-axis plus total area below x-axis. We are given the integral from 0 to 7 on the function f. It is -10. Yeah, here. We are given this integral. This integral by formula is total area above x-axis minus total area below x-axis. Total area above x-axis minus total area below x-axis. It is a -10. Okay, now a above minus a below, it is -10. We want to find a above plus a below. What is that? The answer is low solution. Now this time, it is impossible to compute this integral just based on this integral. This integral is -10. Only based on this information, we cannot tell this integral. Why? Let me give you one example. X minus y is -10. Now, can you tell me what is x plus y? You cannot. Why? Because there are many possibilities. For example, 0 minus 10 is -10. So 0 plus 10 is 10. 1 minus 11, it is -10. 1 plus 11 is 12. 2 minus 12 is -10. But 2 plus 12 is 14. So there are many possibilities. So only given this equation, we cannot determine what is a above plus a below. So the answer to E is impossible. We cannot tell the integral in E. Example 2. Evaluate this integral by interpreting it in terms of areas. By the subtraction rule, we can write this integral as a difference of two integrals. Now we have this and this integrals to compute. To find the first integral, plot the graph of the function x. The graph is the line going through the origin, and the slope is 1. This integral is the net area of the region bounded by the graph of x and the x-axis and between -5 and 5. It is the shaded region in this diagram. This integral is the red area of the shaded region. This region has this triangle as the area above x-axis and has this triangle as the area below the x-axis. These two triangles are equal. So therefore, the red area of the shaded region is 0. In other words, this integral is 0. Now, to find the second integral, we need to plot the graph of this function. The graph of this function is a semicircle. How to see the graph of the function is a semicircle? Let y be the function. Now, let me transform this equation into a circle equation. Take square on the both sides, then we get this equation. Move x squared to the left-hand side, then we have this circle equation. The graph of this equation is a circle. The radius is 5. The center is 0, 0, the origin of the xy plane. This equation contains two functions. One is this function. The second one is y is equal to negative square root of 25 minus x squared. This equation contains two functions. The upper semicircle is the graph of this function, and the lower semicircle is the graph of the other function. Okay, now we have the graph of the function. Then this integral is the area of the region between the graph of the function and x-axis and between -5 and 5. The region is this shaded region in this diagram. Now, what is the area of the shaded region? It is 1/2 of a full circle, So therefore, this integral is 1/2 of the full circle. The circle, the radius is 5. Center is the origin. The full circle area is pi r squared, so pi 5 squared. Then half, so divided by 2. So therefore, this number is this integral. Okay, now go back to the original integral. Original integral is this integral minus this integral. The first integral is 0. Second integral is this number. So therefore, the original integral is equal to 0 minus this number. It is negative 25 pi divided by 2. Example 3. Use only the fact that the integral from 0 to 4 on this function is 32 and use the properties of integrals to evaluate the following integrals. We have 3 integrals to evaluate. Now, consider this integral first. This integral has the same function as the given integral. The difference between these two integrals is the given integral is from 0 to 4, and this integral is 4 to 0. So we need to switch 4 and 0 in this integral by adding a minus sign. When we switch the integration limits, don't forget to add a minus sign. Okay, so this integral is equal to negative. The given integral is 32. So negative 32 is the answer to A, to part A. Now, part B. This integral, the function is different from the function in the given integral. The given integral, the function has number 3, and also this factor is 4 minus x. But the function here has low 3, and also this factor is x minus 4. Okay, now notice the difference. Let's transform this integral into the given integral step by step. Okay, now this is the integral that we want to compute. First, let me take negative from x minus 4 out. Now, so the function is negative x. The factor now becomes 4 minus x. But this function is still different from the function here. Okay, now the coefficient is 1. Let me write the 1 as 1 over 3 times 3. Okay, now move the constant negative 1/3 outside this integral. Then we get this equation. Now this integral is exactly the given integral. It is 32. So this integral is 32. So the answer to B is negative 32 over 3. Now, the third integral. The third integral, what is the difference between this integral and the given integral? This integral is from 4 to 0. The given is 0 to 4 difference. And also, the given function, the function in the given integral is 3, the factor 3, the constant 3. But here, 6, different. Okay, now, after we notice the differences, we can step by step transform this integral into the given integral. Okay, first, 6 is 2 times 3. Let me take the constant 2 outside the integral to get this equation. Next, I switch 4 and 0 by adding a negative sign. Then I have this equation. Okay, now this integral is exactly the given integral. It is 32. So the answer is negative 2 times 32. Negative 64. This is example 3. Okay, now we turn to the second topic today. Second topic is a dummy variable in the integral notation. In this notation, the variable x actually is a dummy variable. You can replace it with any other letter. Say, for example, you can replace x by t. Okay, then we have 2 integrals. Let me call this integral the original integral, and this is a new integral. Original integral and the new integral, they have the same value. They are equal. They are equal. Why they are equal? In detail, okay? Original integral is the net area of the region between the graph of the function f of x and x-axis and between a and b. So this integral is the net area of this shaded region. This shaded region is on the x, y plane. How about the Liu integral? The Liu integral is the net area of the region between the graph of the function f of t and the t axis and between a and b. So this Liu integral is the net area of this shaded region. This shaded region is on the ty plane. But these two, because the two functions, essentially the same function. So these two shaded regions are the same region, essentially the same region. So therefore, this guy is net area of this region, and this is the net area of this region. So these two regions are the same region. So these two integrals are equal. So, in the integration notation, x is not important. You can use any other letter for x. You can use any other letter to replace x, and doesn't change the value of the integral.